Hi, this is Professor Sartor, back with another 10 questions for my college algebra class. This question says, find the equation of all horizontal asymptotes, if any, of the rational function. F of x equals 3x squared minus 2x cubed over 5x cubed plus x squared minus 7x plus 7. So to find horizontal asymptotes, we have some rules that we have to memorize. And those rules are based on comparing n and m. N is the degree of the numerator, and m is the degree of the denominator. So if n is less than m, we have a horizontal asymptote at y equals 0. If n is equal to m, we have a horizontal asymptote that is y equals a sub n over b sub m, and those are the leading coefficients of both the numerator and denominator. If n is equal to m plus 1, we don't have a horizontal asymptote. We have a different type of asymptote, which is called an oblique or a slant asymptote. And if n is greater than or equal to m plus 2, then you don't have a horizontal or oblique asymptote. So for our example, we want to figure out n and m. So looking at the numerator, we have a power on x of 2 and a power on x of 3. We're going to take the highest power, which is 3, to be the degree of the numerator. For the denominator, we have a power of 3, a power of 2, a power of 1, and on the constant, that would be a power of 0. We take the highest one, which is a power of 3. So if we compare these two, we can see that n is equal to m, and that is our second case of our horizontal asymptotes. So we're going to have a horizontal asymptote, and it's going to be the line y equals the ratio of the leading coefficients. So we need the leading coefficient from the numerator, and we need the leading coefficient from the denominator. The leading coefficient is going to be attached to that highest degree term. So remember we said the numerator has degree 3. So we have x to the power 3. The leading coefficient is that coefficient that's attached to that term. So it's going to be negative 2. And for the denominator, we said that's degree 3. So we have x to the third power, and that coefficient attached to that is 5. So the line y equals negative 2/5 is the horizontal asymptote for this rational function. This question says, find the equation of all horizontal asymptotes, if any, of the rational function. F of x equals x squared minus 36 over x plus 6. So to find horizontal and oblique asymptotes, we have this set of rules that we have to memorize, and these rules are all based on n and m. And n is the degree of the numerator, m is the degree of the denominator. So if n is less than m, we have a horizontal asymptote at y equals 0. If n equals m, we have this calculation for finding the horizontal asymptote. If n is 1 more than m, then we don't have a horizontal asymptote. We have this different type of asymptote called an oblique asymptote. And if n is greater than or equal to m plus 2, then we don't have a horizontal or oblique asymptote. So let's find n and m for our problem. So for the numerator, we're looking at the power on x. So this term has a power of 2. This term doesn't have an x at all, so we say that's a power of 0. That's the constant term, has a power of 0. And we're going to take the higher power of 2. So n is equal to 2. Then for the denominator, m, you look at the power on x here, that would be a power of 1. And the power on x here, there is no x, so we say it has a power of 0. So for the denominator, the degree would be 1. Now looking at that, we can see that n is going to be 1 more than m. So that puts us into this third case, and in that case, we don't have a horizontal asymptote. So there is no horizontal asymptote for this example. This question says find the equation of all horizontal asymptotes, if any, of the rational function f of x equals 8x squared over 3 minus x squared. So we have to have these rules memorized related to horizontal and oblique asymptotes. And all these rules are based on n and m. N is the degree of the numerator, m is the degree of the denominator. So the degree of the numerator, which is n, we get that by finding the highest power on x, and that is a 2. For the denominator, we're also looking for the highest power on x. We have a power of 2 on this term. This term doesn't have an x, so we use a power of 0 for that term, and we take the highest power, which is 2. So in this example, m and n are equal to each other, so that's case 2, where n is equal to m. We want to use the line y equals a sub n over b sub n. A sub n is going to be the leading coefficient. B sub n is the leading coefficient for the denominator. So our horizontal asymptote is going to be the line y equals the ratio of the leading coefficients. So we're going to have a fraction where we have the leading coefficient from the numerator on the top and the leading coefficient from the denominator on the bottom. So for the numerator, we have 8x squared. That leading coefficient is going to be 8. For the denominator, we have 3 minus x squared. The leading coefficient doesn't mean that it has to be first. It has to be with the highest power x. So that leading coefficient for the denominator is -1. So the line y equals -8, 8 divided by -1 is -8, is our horizontal asymptote for this example. This question says sketch the graph of the exponential function f of x equals 5 to the x. This is an exponential function because the variable's in the exponent. We're given this table to fill out before we graph it, and then we have some choices here for the graph. So my function is f of x equals 5 to the x. I'm going to fill out this table. They give us x values of -2, -1, 0, 1, and 2. We'll substitute that into the function to get the y values. I'm going to start down here with x equals 1. Substitute 1 in for x gives me 5 to the first power, which is 5. We'll do x equals 2. That gives me 5 to the second power, which is 25. 5 to the 0 power. 5 to the 0 power is 1. We have 5 to the -1. Having a negative in the exponent means that you're going to do the reciprocal of the base and then raise it to that power. So the reciprocal of a base of 5 is 1/5, and then we'll raise it to the first power to get 1/5. We have 5 to the -2. That negative means we're going to do the reciprocal of the base and then raise it to the second power, so we get 1/25. So these are the ordered pairs that we get. Let's plot them, starting with the easier ones. 1, 5, 225. That's probably going to go way off my screen, so just going to make a guess that it's way up here. And then 0, 1, -1 and a fifth. A fifth is 0.2, which is getting it pretty close to the x-axis. We have -2 and 1/25. That's even closer to the x-axis. So now we have these 5 points, and these 5 points connect with each other pretty smoothly. You can guess that as we follow the pattern on this side, it's going to go up to infinity pretty quickly. And on this side, as we go further down the negative path here, our y values will get closer and closer to the x-axis. So our y is getting closer to 0. Y is approaching 0 as x is approaching negative infinity. That's going to give us what we call a horizontal asymptote. A horizontal asymptote along that x-axis, y equals 0. So that looks like answer choice B to me. This question says, use the graph of y equals 3 to the x and transformations to sketch the exponential function f of x equals -3 to the x minus 3. Determine the domain, range, the y-intercept, and the equation of the horizontal asymptote. So let's start off by graphing y equals 3 to the x. I'm going to make a chart. I'm going to choose my x values to be -1, 0, and 1. We'll substitute those in to get the y values. So I'll start with the easy one. 3 to the first power would be 3. 3 to the 0 power would be 1. And 3 to the -1 power, that negative tells us to do the reciprocal of the base and then do the power. So that's 1/3 to the first power is 1/3. And you can see those are the same ordered pairs that they gave us in this chart right here. So that's how they got those values, by substituting them into the equation 3 to the x. So let's see what that picture looks like. So we have 0, 1, 1, 3, and -1 and a third. So we're getting this picture right here. Now the equation that we're looking at is f of x equals -3 times x minus 3. And this is going to be a transformation of 3 to the x. You can kind of see the 3 to the x is there, but we have these extra operations of multiplying by a negative and subtracting 3. So these are going to make changes to that graph. So let's start by talking about what that -3 would be. That -3 is going to be a shift. I know it's a shift because it has adding or subtracting. All shifts will have adding or subtracting on your function. Now that -3 is inside the exponent. So because it's inside the exponent, I know it's a horizontal shift. So I know that because it's inside. Then I know that it's going to go to the right because it's a minus. It's going to go right 3 units. So that -3 is going to shift all the points to the right 3 units. Then we have that negative. This is the -3, and now we're talking about the negative. Now that negative, multiplying by a negative, is going to be a reflection. And because that negative is outside of the exponent, I know that it's going to be a vertical reflection. So it's a reflection because you're multiplying by a -1. It's vertical because it's on the outside of the exponent. And a vertical reflection is up and down, top to bottom. So you're going to do a mirror over the x-axis. So if we were to do these two transformations, we would take this graph, this original graph right here, and we want to shift it to the right 3 and reflect it or mirror it over the x-axis. So that would take this point right here, which is 0, 1. We're going to move it to the right 3. That moves that 1 point to the right 3. Then we're going to mirror or reflect. You see this point is 1 above the x-axis. To reflect it, it will go 1 below. So let me erase. We started with a point on y equals 3 to the x, and we moved it to our final graph of y equals -3 to the x minus 3. Okay, now then we'll do this point right here. This point is 1, 3. We want to move that to the right 3. So we start at 1, 3. We're going to move it to the right 3. If we go 1, 2, 3 over, and then we're 3 above the x-axis, we're going to reflect to be 3 below, to that spot right there. And then we're going to take this point right here, which is -1 and 1/3. -1 and 1/3 would be about right here. We want to move it to the right 3. 1, 2, 3. We're 1/3 above the axis. We're going to reflect, become 1/3 below. So that gives us this picture here. And that is what the graph of y equals -3 to the x minus 3 looks like. Now this question specifically asks where these points move to. So let's talk about where 1, 3 moved to. Remember we started right here. Let me highlight. We started right here at 1, 3. We moved to the right 3. If we move to the right 3, instead of being at x equals 1, we move to x equals 4. So the x-coordinate becomes 4. Now the y-coordinate was 3 above and reflected to 3 below, so that y-coordinate becomes -3. So let's talk about the point 0, 1. 0, 1 got moved to the right 3. So it was at 0 and moved to 3. That x value changes to 3. And that point was 1 above and reflected to be 1 below. So now the y-coordinate is -1. But then for the last point, which started right here, at x equals -1, we move to the right 3, that's going to put us at an x value of 2. The y-coordinate was 1/3 above the x-axis. You reflect it to be 1/3 below, so that's going to change to -1/3. Okay, the next question says, what is the domain? The domain of this exponential started off being -∞ to infinity. We did a few transformations, but the domain stays -∞ to infinity. For the range, we look over here at the starting graph. The range started at 0 and went to infinity, But on our new graph, because of the reflection, our range starts at negative infinity and goes all the way up to 0. So our range goes from negative infinity to 0, not including 0. What is the y-intercept? Okay, so to find a y-intercept, we let x equal 0. So f of 0 is negative 3 times 0 minus 3. That's negative 3 to the negative third. Negative 1/3 to the third. The negative in the exponent changes it to the reciprocal of the base. And that 1/3 to the third is 1/27th. So we have negative 1/27th as our y-intercept. Then it says, what is the equation of the horizontal asymptote? Okay, your horizontal asymptote on the original graph was right along the x-axis. That's the line, the horizontal line, y equals 0. And since we only did a shift to the right and a reflection, our horizontal asymptote didn't move, and it is still y equals 0. This question says, solve the exponential equation using the method of relating the bases by first writing the equation in the form e to the u equals e to the v. So this relating the bases method says that if we can write it in this format, e to the u equals e to the v, then the exponents have to be equal to each other. So it allows you to simplify from an exponential equation to something that's a little simpler. So our equation is e to the x squared to the fourth equals e to the 144. Now my right-hand side already looks like what they want it to, e to a power, but my left-hand side needs a little bit of simplifying. So I'm going to use on the left-hand side something called the power rule for exponents. And the power rule for exponents says that if you have a number to a power and then raised to another power, that you're going to multiply those powers together. So that's what we're going to do here. We've got a power raised to another power, so we're going to multiply those powers together to get 4x squared. Now that we've made the bases the same, the exponents have to be equal to each other, so we can simplify this equation to 4x squared equals 144. We'll divide both sides by 4 and get x squared equals 36. From x squared equals 36, we can square root both sides to get x equals plus or minus 6. And those are our solutions, x equals 6 and negative 6. This question says, solve the exponential equation by the method of relating the bases. First, rewriting the equation in the form b to the u equals b to the v. So this relating the bases form that we want, if we write it in this form, b to the u equals b to the v, once the bases are the same, the exponents have to equal each other. So we can take an exponential equation and turn it into something that's a lot simpler. So our question is 49 to the x equals 1/7 to the x minus 3. We want to make the base on both sides be the same. You can see right now they're not the same. But hopefully you recognize that you have 1/7 and the number 49 is a power of 7. I can change 49 to be 7 squared, and I can change 1/7 to be 7 to the negative 1 power. That would allow us to have the same base on both sides. So let's make those changes. 49 is 7 squared. 1/7 is 7 to the negative 1. Then I'm going to use my power rule for exponents and multiply these powers together. So that's going to give me 7 to the 2x equals 7 to the negative 1 times x minus 3. Now that the bases are the same, the exponents have to equal each other. So that's using relating the bases. We have 2x equals negative 1 times x minus 3. And we'll solve that equation. So I'm going to use the distributive property to distribute that negative 1. That's a negative x plus 3. Now I have a linear equation. I want all the x's onto the same side, so I'm adding x. That gives me 3x equals 3. Divide both sides by 3 and I get my solution of x equals 1. This question says solve the exponential equation using the method of relating the bases by first rewriting the equation in the form e to the u equals e to the v. So this relating the bases method wants us to write it as e to the u equals e to the v. Once we get it written in this format, we can say that the exponents have to be equal to each other. So because the bases are the same, the exponents have to be equal to each other. So it allows us to simplify from an exponential equation to a nicer type of equation. So let's try that with this example. Our equation says e to the x squared equals e to the x times e squared. On the left, I already have what I'm looking for, a base of e. On the right, I've got to simplify using my rules of exponentials. So one of the rules is called the product rule. And the product rule says if you have a to the power m times a to the power n, when you are multiplying, when the bases are the same, you're going to add the exponents. So on our equation, I've got the bases being the same, and I'm going to add and I'm multiplying, and I'm going to add those exponents together to get x plus 2. So now I have the bases the same, and based on relating the bases, the exponents have to be equal to each other, and I get the equation x squared equals x plus 2. This is a quadratic equation. I'm going to move all the terms to the same side and try to factor. So x times x would give me x squared. 2 times 1 would give me 2, and I need a minus on the 2 and a plus on the 1 to make sure I get negative 2 when I multiply and negative 1 when I add. Then I'm going to use the zero product property and set each factor equal to 0. Solve by adding 2 to both sides. Solve by subtracting 1 on both sides. And I've got my solutions of x equals 2 and x equals negative 1. This question says, suppose that you have $6,000 to invest. Which investment yields a greater return over a 10-year period? 7.44% compounded daily or 7.5% compounded quarterly? So looking closely at this, I can see it says compounded daily and quarterly. So I'm going to use the compound interest formula, A equals P times 1 plus R over N to the NT. Now we're given that we're going to invest $6,000, and that is our principal. We're going to invest that over a 10-year period, and that is our time. Then we're given 2 different interest rates, 7.44 and 7.5. So these are both R. We're going to have to calculate our formula 2 different times. And then it says it's compounded daily, and compounded daily will give us the value of n. N is the number of times in 1 year. So because it's daily, that'll be 365. And then the other one says quarterly, and that's going to be 4 times a year. So we need to calculate the formula once with one interest rate and once with the other interest rate. So we have our principal of 6,000. We're going to multiply that by 1 plus the interest rate. We're going to turn that into decimal form. We move the decimal place 2 places to the left. So that's 0.0744 over 365 because we're doing compounded daily. And then raised to the 365 times 10. So in my calculator, I can just type this fully out, 6,000 parentheses 1 plus 0.0744 divided by 365, close parentheses. I'm going to use this caret key, which creates the exponent. And in the exponent, some of you may need parentheses, some of you don't. I actually don't need parentheses for this calculator, but we're going to do 365, parentheses 365 times 10, and then close parentheses for that exponent. So that's going to give us, after 10 years, our $6,000 grew to $12,625.06. I rounded to the nearest cent. Then for the other investment, we're still starting out with $6,000. Our interest rate is different. We're doing 7.5%. We still need to turn that into a decimal, so that's 0.075. We're compounding quarterly, so we're going to do 4 times a year. And in the exponent, 4 times the 10 years. So we can type that in our calculator, 6,000 times 1 plus 0.075 divided by 4. Close parentheses, we're going to create that exponent. Some people need parentheses around the exponent, 4 times 10, and close parentheses. So for the second account, paying 7.5% interest, we would have $12,614.10. So which one is a better investment? That's going to be whichever one gives you more money, and that is the first one, which is 7.44 compounded daily. So this question says, the relative growth rate of a certain bacteria colony is 25%. Suppose there are 7 bacteria initially. Use the exponential model P of t equals P naught e to the kt to answer the following questions. Find the function that describes the population of bacteria after t hours, and how many bacteria should be expected after 2 days. So we have to know what this formula stands for. We have P of t equals P naught e to the kt. So the P naught is our initial or starting amount. And so for our problem, it says 7 bacteria initially, so we're going to put 7 in that position. The value of K is going to be either our growth or decay rate. So the 0.25, I turn that percentage into a decimal, is going to go in that position, because it says we have a growth rate of 25%. So for our part A of this problem, we're just substituting those 2 things in, 7 in for P naught and 0.25 in for K. And that's the answer to part A. Okay, then in part B, it says after 2 days, how many bacteria are expected? So this is a little bit tricky because in the part before, it mentions hours, but in the second part, it mentions days. So our formula is based on our time being in hours. So we have to convert 2 days to hours. So we're going to multiply 24 hours in a day and say that that's 48 hours. 2 days is the same thing as 48 hours. And then substitute 48 hours into what we got from part A. So that's 7. We started off with 7 bacteria, a growth rate of 25%. And after 48 hours, what will we have? So let's use our calculator. 7, we need the E. So I hit the second and then natural log button to get e to the x. Then we put in 0.25 for the exponent, that's the growth rate, times 48. And I have, after 2 days, 1,139,283. Does say to round to the nearest whole number, so I need to round that last digit to a 4. And what is that? 1,139,284. So those 7 little bacteria grew to 1,139,284 after just 48 hours.